Here we have question 9. This is 2018 Leaving Cert higher levels. So the first one we just have to fill in a table. So it's step number 0, 1, 2, 3. So 0, 1, 2, 3. And then we want to fill in the number of black triangles and then the fraction of remaining. So in the first one, the number of black triangles is 1. So the fraction remaining is 1. And then we're also told this. In the next one, the number of black triangles is 3 and their fraction is 3 over 4. Here the number of black triangles is 9. In the next one, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 by 3 is 27. And then 1, 2, 3, 4 by 4 is 16. So 16 by 4. So the total number is going to be 27 over 64. And then write an expression in n for the number of black triangles in step n. Well, we can see that these are all powers of 3. So the number of black triangles in step n is going to be 3 to the power of n. So step k is the first stage when the number of black triangles exceeds. So the number of black triangles is greater than 1 by 10 to the power of 9. So first I'm going to let it equal to. So 3 to the power of n is equal to 1 by 10 to the power of 9. So log of 3 and then 1 by 10 to the power of 9 is equal to n. So log of 3, 1 by 10 to the power of 9, and then I get that n is equal to 18.863, but they want the number when it exceeds 1,000 million. So the first stage that it exceeds it is going to be 19. And then step h is it. So now I have to get a general term for my fraction of the triangle. Well, my common ratio for all of these is 3 over 4. So I can say it's a geometric series. So the first term, a is 1, the ratio is 3 over 4. So the general term is going to be of my geometric series. I'll just get that out. So it's going to be a or n minus 1. So the first term, a, and then or is 3 over 4 and then n minus 1. So I'm going to figure out when this general term is going to be less than 1 over 100. But note that I let step number 0 be pattern number 1. So whatever step I have, whatever pattern number is, the step number is going to be just 1 less than that. So I have to say that's less than 1 over 100. So first I'm going to let it equal to, so 3 over 4 n minus 1 is equal to 1 over 100. So log of 0.75 and then 1 over 100 is equal to n minus 1. So that's going to be log of 0.75, then 1 over 100, so 1 over 100, and then I get that 16.007 is equal to n minus 1. So then n is going to be 17.007, but they want the first pattern stage number when it exceeds. So the pattern number anyway, it's not going to exceed until it's 18, but pattern number 1 is really stage number 0. So pattern number 18 is really step number 17. So it's going to be step number 17. And then what fraction of the original triangle remains after an infinite number of steps of the pattern? So after an infinite number of steps, so we can see that the fraction of the triangle remaining is 3 to the power of 4. What we can do is get we can write it as 3 to the power, I'm not sure exactly what answer they wanted for this, but it can be, because this is the fraction of the triangle remaining, so it can be 3 to the power of infinity over 4 to the power of infinity, or all of this to the power of infinity, or they could have asked the limit as n tends to infinity. I'm not sure which one they were looking for here of this, and then the limit as n tends to infinity is going to be 0. So either one, I'd say, is what they were looking for there. And then the side of the side in step number 0. So now they're doing a step and a perimeter. So in step number 0, the perimeter is 3. So step number 1, 2, 3, 4. So in step number 1, so I just have to get the side length. So it was divided into 2. So it's going to be a half the length of one side, and then the perimeter is going to be 3/2, and then there are 3 of them, so the perimeter is going to be 9/2. In the next one, so they already have filled in this one here for me. So 2, and then in pattern number 3 is in perimeter step number 3, and then so 2, and then step number 3, well, it's after being put. Now there's 1, 2, 3, 4, 5, 6, 7, 8. So each length is going to be 1/8, and 1/8 by 3. So the perimeter of each triangle is 3/8. But I already got the number of triangles, and there's 27. So 3/8 by 27, I get 81/8. But I can see that what's really happening is here, my ratio is, say, 3/2, because if we put 9/2/3, we get 3/2. If we put 27/4 and put that over, we get 3/2. So our ratio is 3/2. So instead of counting out in step number 4, I'll multiply 81/8 by 3/2, and then in step number 4 I get 243/16. So that's in step number 4. Write an expression for the number of so that's give the total perimeter of the black triangles in step number 35. So I'm going to form a geometric sequence, so general terms. So Tn is a or n minus 1. So my first term is, so I'm going to say step number 0 is pattern number 1. So in pattern number 1, the first term is 3. The ratio is 3/2, and then n minus 1, and I'm going to let that equal, so I'm going to figure out for this. So in pattern number 1 that I've let, it's really step number 0. In pattern number 2 that I have, it's really step number 1. So if I want to deal with, say if I have step number 0, it's going to be really pattern number 1. But if I have step number 35, it's going to be pattern number 36. So 36, take 1, so 3/3/2 to the power of 35, and then I get 4368328.818, and they say correct to the nearest unit, so 4368328, so 329, so correct to the nearest unit. And then use your answer in part CI. So the answer that I got in D II was 436 436 8 3 2 9. So use your answer. This is for the perimeter in step 35. Perimeter in step 35. So the perimeter of a general term for the perimeter is 3/2 n minus 1, and then for my number of what the fraction of the original triangle remaining is another one they wanted me to do, use into account. So the fraction of my original triangle remaining is going to be 3/4 to the power of infinity, but I got the limit as it tends to infinity, which I got the fraction was tends towards 0. So use your answers to comment on the total area and total perimeter in step n. Well, the fraction of the total So I got the perimeter, the perimeter of the triangles is going to be getting greater. So as the perimeter instead of n of n tends to infinity. So for the area, is going to be equal to the area at the start. So what we started with, so say the area originally multiplied by the fraction of, say, what's left, but the area at start multiplied by so it's going to be the fraction of black triangles take up. But as the fraction of black triangles is in the form 1 over n or 1 over 4, so that tends towards 0. So the area, the limit of the area as the fraction, which is 3 over 4 to the power of infinity, the limit of this as n tends towards infinity is 0. So the area must be tend towards 0 for that as well. So say for the perimeter, 3 and then 3 over 2 to the power of n minus 1. So if I want to get the perimeter in step n, well, this is a top heavy fraction, so the perimeter is going to be it's going to tend to infinity. So the perimeter is going to be the perimeter can tend to infinity. But it depends on what way we look at it. If we were to get if we're doing in this way, we can get that the area tends to 0 and then the perimeter tends to infinity. So the perimeter is getting greater and then the area is tending towards 0.